Hello, stat students. This is Mr. Budick. Wanted to make a video for you today for today's activity, today's lesson. We're starting chapter 6, learning today about discrete random variables. So I wanted to take you through what the activity is going to look like. If you notice in the room, there are 4 posters, one for first hour, one for second hour, one for third, and then one for fifth. The fifth hour is on the right side whiteboard as you face the Clever Touch screen. So find your poster, and basically we're trying to get a probability model for the number of children in your family, including yourself. So count up the number of children, including yourself, any stepbrothers, stepsisters, half-brothers, half-sisters, adopted brothers or sisters. How many children in your family, include yourself. Take your pencil, put a tally in the correct number, 1, 2, 3, 4, 5, 6, 7, 8. If needed, because you have more than 8, please do add a box and make a tally for the number beyond 8 that you have. And then once everyone has done that, if you could, take a marker and then put the actual number. With the number, however, put it as a numerator out of the number of people in class. So for first hour, for example, 26 total students, if everyone is there. And there's 3 people with 2 people in the family, 2 children in the family. Okay, so 3 is located in the box for 2. You would have 3 over 26. Okay, so let me show you an example of some data if this were our class. Obviously, it's not because we don't have 30 students in any of our classes. But here's what it would look like. So there's 3 students that are only child. So 3 out of the 30, or 7 out of the 30, 9 out of the 30, 5 out of the 30, 3 out of the 30, 2 out of the 30, 0 out of 30, and 1 out of 30. Notice they all have 30 as the denominator. Your bottom number is the number of students in the class for today, depending on your hour and depending on who's there and who's absent. Okay, but basically, all the probabilities are going to be between 0 and 1, and at the end, they should all add up to 1. Okay, so go ahead and make sure, pause the video, and make sure that you filled in the chart and got the necessary information, and then you can add in on your actual sheet that you should have on you at this time. All the sheets are on the front little table for each hour with a label with a post-it note: first hour, second hour, third hour, and fifth hour. Okay, so pause the video and fill that information in. Okay. All right, so hopefully you have the table filled in, okay, and then answered the first couple of questions. Is this a valid probability model? The answer is yes. All the probabilities should be between 0 and 1, and when you add them all up, they should add up to 1 whole. Okay, 26 out of 26, or 25 out of 25, 27 out of 27, 24 out of 24, depending on the hour, the number of students that we have in the classroom. Now, number 2, is it possible to get 5.7167 as a value for x? Well, no. Okay, it's impossible to have a fraction of a human being. Okay, we're not going to take part of a child or part of a brother or sister. Okay, as an example of a discrete random variable. Obviously, there's going to be gaps now between 1 and 2, not having part of a person. You either you're the only child, or you have 2 children, or 3, 4. You don't have a number in between 4 or 5, or in the case of number 2, in between 5 and 6. Okay, so these are discrete random variable examples. There's gaps in between them. Okay, now when it asks you to make a histogram, okay, rather than just starting it from scratch, there's a couple different options in Google Classroom with the slides and the video that I shared with you. You'll also see a link for the Staplet, and it's labeled discrete random variables. Now, enter in the information, so all the X values 1 through 8, or if your class had, somebody has 9 or 10 or 11 or 12 children in their family, obviously add those necessary rows, fill in the appropriate probabilities, and hit begin analysis. It will create the histogram for you, okay? Labeling the horizontal axes, okay? The numbers 1, 2, 3, 4, 5, 6, 7, and 8, or depending on how big you need to go. And it will also tell you the mean and standard deviation. In the coming days, okay, we'll talk more about standard deviation, but the mean and what that all entails. What does that tell us? Okay, what information are we able to gather from that mean? Okay, we'll talk about that in just a little bit. So anyway, making the histogram right there on the staplet. Also, if you wanted, you could make that histogram on your calculator. So entering in the information on a list and spreadsheet, just like we've done many, many times before, label the X 1, 2, 3, 4, 5, 6, 7, 8, and the appropriate probabilities. Okay, I used the example data set that we had before. Add a page, data and statistics. Okay, you're going to label this your X variable, okay? And we want to change this right away to a histogram. So we're going to go to plot type, menu, plot type, histogram, and then go to menu, plot properties, and we want to add Y summary list, okay? And then hit probability, and boom, there is your histogram. And certainly you could adjust your bin widths to make it centered on those values, menu, plot properties, histogram properties, bin settings, okay? Equal bin width, variable bin width. So we want it to be that, okay? Oops, control undo, sorry about that. So menu, histogram properties, bin settings, equal bin length. So we want the width to be 1, but we want to align off of the half. So that way they'll all be centered on there. You can also go window, zoom for the data, and there it looks pretty much exactly like the histogram did on the staplet. Okay, so that would be how you could create that histogram on your calculator. Okay. If you need, certainly rewind the video to go through those steps again, however it needs to be accomplished for you, okay? All right, from there, okay, after you've got your histogram, describe its shape. Well, obviously, for this particular data set, okay, we have it skewed to the right, single peak at 3 children. Okay, obviously, our data for your class, first hour, second hour, third hour, or fifth hour, could take on a different shape depending on how the probabilities lay out, where the bulk of students have the number in their family, number of children. Okay, all right. So then let's answer a few probability questions that come up for your data set. Okay, so for this particular one, describe in words what the probability of X greater than 3, greater than or equal to 3 means, and then find the probability of X greater than or equal to 3. So for anybody, the probability of X greater than 3, that's the probability that a randomly selected student has 3 or more children in their family. So for this particular class, for this particular data set, greater than or equal to 3, if we look, we've got 9, 5, 3, 2, and 1. Do a little math there, and you add that all up, hey-oh, you're going to get 20 out of 30. Okay, so answer the question for your class, depending on the probabilities for those numbers. But the words that are written here, that's going to be the same for everybody. Describe in words what the probability X greater than 3, and then find the probability X greater than 3. The probability that a randomly selected student has more than 3 children in their family. Okay, notice more than, not equal to. So now we're just looking at 4, 5, 6, 7, and 8, and any numbers that you may have that are bigger than 8 for your particular class. But for this one, 5 and 3 and 2, and 1 for 11 out of 30. Okay? Notice the difference between those two. Then it says, find the average of the x values. Well, if you just add up those x values, you're going to get a total of 36. 36 divided by the 8 values, you're going to get an average of 4.5. Doesn't really tell us much, okay? Just the average of taking the sum of the first 8 numbers and finding the average, 4.5, okay? But if we understand what we're looking at, we can see that the number 3 and the number 2 should certainly take on more strength than the others because those occur quite often. Okay, the 3 definitely because it occurs the most. Okay, so we need to instead do what's called the expected value, the mean of x, the summation of all the x values and their probabilities. So written out, you can see how long that takes to do by hand. Okay, obviously the Staplet computed that for us very, very quickly. The average, 3.3. Okay, so how do we do that on our calculator, you ask, without having to manually add all that up and write it all out and add it by hand? So if we have in our calculator, let me pull up that screen. Okay, so recall that we entered in all the data. Okay, there it is with the probabilities. Okay. Now you can do this right in the list and spreadsheet. It'll give you everything you need. Otherwise, like I like to do, add a calculator page. Okay. Then go through the steps. Menu, statistics, stat calculations. Oops, went a little fast there. Cancel. Menu, statistics, stat calculations. One variable statistics. Okay. Number of lists, we just want 1. Okay, now it's a little bit different here. So our X list is still going to be X, but the frequency list, that's going to be where we have our probabilities. Okay, so then click OK, and notice, voila, it'll give you the average right there, 3.3. Okay, outstanding. There is the average value for our particular data set, our example. Can you find the average for your class? Okay, going through those steps and understanding how that all works. Okay, this formula that you see right here is in your packet, and we certainly could talk about that tomorrow, Tuesday, when I return. Okay, all right. So with all that, okay. Some important notes to take down. Okay, so probability distribution. Okay, you have your x variables and the probabilities located right underneath. Okay, probabilities will add to 1, and they all fall between 0 and 1. Okay, discrete random variable, our learning target for today, takes a fixed number of values with gaps between. So 1, 2, 3, 4, 5, 6, 7, 8. Nothing in between those numbers. Okay? Think about things that we've done before, Math 1, when you learned about sequences. Okay? Inputs, only positive integer values. It went from dot to dot. You didn't connect the dots, okay? Because it was discrete. It wasn't continuous. So examples of discrete variables that you've used in previous classes. Okay? Also, histogram, okay, the values of x, and on the vertical axes, their probabilities. Okay? The mean expected value, okay, of your discrete random variable, okay? The summation of all your x values times their probabilities. So adding each one up, multiplying it by the probability, okay? The likelihood that that number will take place, okay? All right, I'd like you to pause the video now, make sure that you have the first page done, make sure you have those notes, and then certainly try out the check your understanding, the number of Home Alone movies watched, okay? And go through those questions and answer them, and then unpause the video and see how you did. Okay? All right, so I hope you had a chance to go through the questions and answer the check your understanding on the back. Okay, so part A, write the event the student has seen 3 Home Alone movies using probability notation. Then find this probability. Okay, the probability x equals 3, okay, equals, well, 1 minus, now notice why I subtracted off these values right here. Well, I first of all had to figure out what is the value of 3. And we know that all of these need to add up to one whole. So what was missing? 0.08. Okay. All right, explain in words what the probability x greater than or equal to 3 means. What is the probability? The probability that a randomly selected student has seen at least 3 Home Alone movies, 3 or more. Okay. And then, obviously, add up those 3 probabilities, 0.08, 0.02, 0.01 for 0.11. Probability of x greater than or equal to 3. And then part C, make a histogram. So if you plug that data into the Staplet or your calculator and go through the steps, your histogram is going to look something like this. Okay, and this is also going to be skewed to the right with a single peek at one movie. Okay, so more often than not, people have just seen one Home Alone movie, perhaps, probably, more than likely the first one. Okay. Calculate and interpret the expected value of x. Okay, so we got the expected value. Okay, we add up all of the values of x and their probabilities to get the sum of that. We find it's 1.43. What does that mean? If many, many high school students, okay, because we are taking data from high school students, okay, are randomly selected, the average number of Home Alone movies they have seen is about 1.43. Now notice that expected value takes on a decimal. Okay, when we're doing averages, okay, that's when we have those decimals. It's no different than when you're watching Sports Center and they're going through the highlights of the Milwaukee Bucks and talking about Giannis or Lillard. Okay, they give their average scoring points per game. They usually have a decimal included there. Okay, because obviously they've played many, many, many games. But as far as talking about the number of points they scored for that game, 20, 30, 36, 34, they don't include the decimal. Okay, so when you're talking averages, that's certainly different than when you're just taking on that specific value when you're going through the process initially. How many points did you score that game? How many children are in your family? How many movies of Home Alone have you watched? Okay, but then once we've taken many, many students or many samples, now we can start talking averages. Okay. Certainly, if you have any questions about today's activity, certainly feel free to message me, reach out, email, or text, whatever you prefer. Okay. Hopefully, you're having a great day so far. Make sure that you do have the front and back completed of today's activity of how many children are in your family. Okay. At this time, okay, the video is going to be done here in about 10 seconds. Please do go into Clever and Sapling, okay, and go ahead and get started on 6.1. Try to keep pace with Chapter 6, going through the Sapling questions. Okay, you'll notice 6.1 is only 17 questions long, so not too bad. So go ahead and get a jump start on that. Hope you have a great rest of your day. Thank you so much for your time. Bye-bye.